So you could hear me, right? Right. Bismillahirrahmanirrahim. 3, 2. Good day, everyone. My name is Fahmi, and today I'll be doing my PSM2 final report presentation slide. The title is Comparative Study on the Performance Sequential and Non-Sequential Deep Learning Model when it comes to phishing detection. There is a lot of things that we will discuss throughout this video. These are the things that the agenda that we will walk through. So without further ado, let's get straight to the presentation. The first thing is that there is a staggering statistic that says that almost 72% of all reported incidents has been attributed to phishing attacks. Now, the problem that exists in this space, the current space right now, is that traditional, static, rule-based filtering, like blacklist or whitelisting, are often very poorly done or very ineffective when it comes to dealing with a very dynamic attack, dynamic injection, dynamic vulnerability, such as zero-day social engineering attacks. Now, the evolution that we have done so far is that we have implemented AI, where we have implemented AI in terms of our cybersecurity domain, which requires a much more dynamic approach rather than a very static approach. Now, text clarification. Okay, so the hypothesis that we have the hypothesis for this experiment. The first thing is that we was a null hypothesis, which is that there is no major difference between sequential and non-sequential performance when it comes to phishing detection. However, there's an alternate hypothesis, which is what's written here, which is that sequential model should theoretically, I say theoretically, outperform the sequential model when it comes to phishing detection. But we will see if that alternate hypothesis is actually true or not at the end of this presentation. There are two models that we are comparing. First is sequential, second one is non-sequential model. Now, non-sequential model often process data in a very ordered manner. They retain memory of past input. They capture the grammar and the semantic flow. However, they often require high computation costs and they struggle with vanishing gradient problem, which RNN is often struggling with that. Now, in the non-sequential model, they often process input regardless of the sequence order. They focus more on pattern recognition and feature extraction. Theoretically, they should really struggle when it comes to long sentences of long emails that require understanding of long-range contextual meaning. Now, the methodology that we go with is that we data source, we gather sources from Kaggle dataset, Nazare dataset, Zenodo dataset, and then we merge them to become what we call as merge corpus. And all these datasets, we will pre-process them. We will remove HTML tag removal. We will use BB tokenization throughout all four model. And then we use stop words will retain only for sequential. Non-sequential model, we will remove the stop words. And then we will use modern design in terms of 80-20 split. So 80% is being used for train, 20% is for testing, and then we use consistent hyperparameter baseline, which is that everyone will use the same hyperparameter tuning. And last but not least, we will evaluate them according to the standard metrics such as accuracy, precision recall, F1 score, and also time and also hardware utilization. Now let's talk about chosen dataset. This is a very interesting part. So we have three datasets that we chosen, but throughout this whole experiment, we only tested on three technically. There's one dataset that's not included here, which is the Zenodo dataset. Now, when we were doing the Zenodo dataset, when I was testing the Zenodo dataset, we were getting not a number for standard deviation, which shows that whenever we run on Zenodo dataset, we only get one successful run because we run it 5 times actually to get the average, and we couldn't get any potential viable result from Zenodo dataset. Now, there are a few reasons that could contribute to it. Now, it's because it could be because it's a balanced dataset, so therefore it's hard for it to capture any pattern, any real pattern. It could be because the dataset is extremely small. It only has like 2,000 emails, and so because we use VB tokenization, so therefore there wasn't enough subword tokenization that allow us to capture any meaningful pattern. So that's why Zenodo is actually being excluded. I did actually in the report why it's being excluded. So we only use Kaggle, we only use Nazare, and we use merge, which is the combination of Kaggle, Nazare, and Zenodo itself. Now, what's the result that we get? Now, this is one of the results that we get for one valuation metric on one dataset. And as you can see, the non-sequential model consistently outperformed the sequential model. Now, if you go and take a look at any evaluation metrics, regardless of precision, recall, accuracy, and on any data set, you will see the same pattern, not the exact number specifically, but the same pattern. Non-sequential model will always outperform sequential model by a margin, right? That's been the consistent theme throughout our empirical result. In terms of computation, this is very interesting because sequential model again take a longer time to be trained, right? And so if you think about it, sequential model take a longer time to be trained, but they don't really yield a very positive outcome, a very positive result. So they don't really seem from this situation to be the most suitable model to be chosen. Sorry. And so therefore, we would say that they oftentimes consume a much more computational cost rather than non-sequential model. Let's evaluate the model instability. As you see, RNN is just like widely fluctuate across every epoch. LSTM is a little bit better, but still not at the smooth end. And non-sequential model always converge, exceptionally clean, rapid convergent, and often after within 2 epochs, and with zero signs of overfitting, right? Now, the precision false alarm is something that is a very interesting evaluation to do because in real life SOC, in real life security operation, false positive matters a lot because it can hinder the performance of the user. If user kept on being flagged for emails that shouldn't be malicious, and then that's gonna bog down their operational day-to-day experience. And so, as you can see, RNN is very troublesome when it comes to the ability to detect false positive. They often miss, they often classify emails that are not phishing to be phishing. In simple words, all right. That's the issue that they had. Again, non-sequential always outperform non-sequential model when it comes to almost every metrics. Why is that the case? Why is that the narrative? Because one of the alternate hypotheses that we have was that we believe sequential will perform better because they can understand semantic understanding and they can capture long-term dependency and they go with the flow of the grammar. Why don't they perform well? Well, maybe the hypothesis that we put forward is the finding that we find is that when it comes to phishing, they often relies on patterns and keywords rather than actually understanding the whole email of itself, the contextual narrative flow. The second factor could be, which is the strongest factor, I think, is the BP factor. Why do I think of that? Because initially, I use Keras tokenizer for sequential model and BP tokenizer for non-sequential model. When I use that method, the performance is almost unanimous throughout all model. Almost every model got around 95th percentile when it comes to performance. But when I use BB for all model, suddenly sequential model performance take a tank to them. And it's because BB capture subword very effectively. So once you have captured subwords effectively, there is technically, logically, no sense for you to understand the semantic flow anymore. Because you've captured subwords, like phishing. So they take fish and they take shing one end. So that's what capturing subwords actually means. So I think that's the reason why BPE is so overpowered that the use of BPE or non-sequential model outperform any pros or any advantages that sequential model has over non-sequential. This is the statistical validation that we do to make sure that our tests are not random testing. Okay, we tested them on 5 independent experimental result run, and performance gap is statistically significant. So therefore, the result is not a product of random variation. Hence, we can say the null hypothesis is rejected. As the original hypothesis, sequential superiority is formally overturned. Yeah. So I did talk about hyperparameter optimization strategies. So we figured out like what is the best hyperparameter tuning settings to be used on every model. And then there was a suggestion from my supervisor to use grid random or exhaustive grid search or Bayesian optimization. But particularly due to time and competition constraint, we only settle on just one model to be used as a baseline. And we optimize the learning rate by assign layers, we drop out, and so forth. And I did run multiple testing on different numbers. And the final configuration we get was estimated sequence length is 400, the upper limit is 64, and the dropout is 0.5. And so this is the thing that this is one of the flaws of this system, which I will talk about in the next slide, which is, as you can see, the first flaw that we have in this study is that the architecture, as mentioned. So we use LSTM rather than these are quite basic models. So Maybe for future work, we could expand it on a different kind of deep learning model, such as transformer based model, such as BERT, or even a hybrid model like a CNN and LSTM merged together. Maybe we would yield a different outcome, right, rather than just using a very basic model. The next one is dataset scaling. Maybe we would require a much more bigger dataset. The biggest one we got was 18,000 email. Maybe that's not big enough. Maybe we should try a bigger dataset. Maybe we would yield a different result when we use a bigger dataset. And the last but not least, the one that I want to make a point from the last slide, which is that we should tune every model to their best level. And but that would require quite a long time and exhaustive amount of time to test one by one configuration. And so future work should use exhaustive grid searches to our model. That's recommended. So let's review back the achievement of our objective. We had successfully. Oh my god, my nose. Review the literature and deep learning based machine detection, focusing on algorithm design, dataset based techniques, and evaluation metrics. We pre-process every dataset, cleaning them, tokenizing them using the same tokenizer. We develop and train post-segregation non-segregation model, and last but not least, we compare the performance, and we were able to get the result, and then we make an analysis of the result, and then we draw a conclusion from it. And so all of our objective has been achieved for PSM1. And with that, I conclude the end of this experiment or this thesis. Thank you so much. I'll see you again.